Okay, we're going to take things up a notch here. The next component that we're going to be creating is going to be an integrated circuit or an IC. Um, different integrated circuits have different pinouts, so we're going to be needing to make a new schematic symbol for this integrated circuit that I've chosen. And as I've also mentioned before, many different integrated circuits have different footprints, so I made sure to choose a chip that has a footprint that's not already in our Altium Libs. So if I go to DigiKey here, I picked out this chip here. This is basically just a temperature sensor. Um, it senses the temperature of the surrounding area or of the chip, and it basically communicates that temperature value via I squared C out to your microcontroller or whatever system it's communicating with. So this is the data sheet for the chip. Let's just assume that I've read through this data sheet, which I really haven't, and it's up to spec with the design I want to implement it in. Um, so usually when you have a data sheet for a chip, you're going to see a section that has a picture of the chip with all the pins labeled with numbers and their respective names. And also, if you scroll down, there will be a little table of all the pins and their descriptions. So we know pins 1 and 2 of this chip are going to be for your I squared C bus. Um, pin 3 is going to be for over temperature shutdown. So if a certain temperature value is reached, this pin will be pulled down to ground, so you can have that feed into a GPIO of a microcontroller and have that just shut down the system if there's like an over temperature condition. Pin 4 is ground, obviously. Um, and then pins 5, 6, and 7 are for your I squared C addressing. So depending on whether you pull these pins up to VCC or pull them down to ground, this will change the last 3 bits of the I squared C address of the device. If that's a little bit confusing to you, don't worry. You don't need to understand how I squared C addressing works in order to create a schematic symbol here, so don't worry about it. And then pin 8 is going to be for VCC or your power. So that's great. So this is basically a section of the data sheet you want to refer to when you're going to be making the schematic symbol, because you're going to want to kind of replicate this. Okay, so to create a new schematic symbol in Altium, you're going to go to File, New. You're going to go to Library, and then Schematic Library. Let's just get the Properties panel open here. And we're going to save this file. We want to save it in our MMRT Altium Libs folder, the one that's managed on GitHub. And since this is a schematic symbol, we're going to save it in the SCH folder. The name of this file should be the same as the manufacturer part number. So we're going to put it there. So I'm going to paste that. Save. Perfect. So the next thing you're going to do is we're going to want to populate our properties panel with some information. So the design item ID is also going to be the name of the part number. The designator is going to be U question mark. So whenever we're going to be making we use the letter U basically to designate an IC, and remember that question mark is just a placeholder. The comment, we're going to type in equals part number. When we put this in, that means Altium will populate this comment section here with the part number that we enter in the Excel spreadsheet. And then the description, if we do the same thing and type in equal description, Altium will take the description of this IC that we put in the Excel spreadsheet and we'll paste it here when we drag the component into our design, right? So now that that's out of the way, let's actually get into the business of making the symbol itself. Since this is an integrated circuit, we're going to have to create basically a rectangle with a lot of pins on it, and you'll see what I mean. Um, Altium has this handy tool called the Symbol Wizard. So if you go to Tools and then Symbol Wizard here, click on that, um, it'll automatically create this IC schematic symbol for you. And basically you can change the number of pins. So if we look, this is going to be a, let's just go here. This is an 8-pin chip. So let's get this going. 8 pins. And then the layout style, so you have a bunch of different layout styles. So if you want, your symbol to look like this, if the chip is a quad side chip, or if it's like a connector, stuff like that. There's a bunch of different options. Most of the time, we're going to be using this dual inline layout style. And then what you do here is for each pin, you have it already numbered for you. And then you can just enter in the display name for these pins. So if we look, we know pin 1 is going to be called SDA, or serial data for I2C. So if I type in SDA, it'll pop up there. And for pin 2, I know that's going to be SCL, so I can do that. Pin 3 is going to be OS. Pin 4 is going to be ground. And they can do the rest. So we're going to have A2, A1, A0, and then VCC. And then we'll type in VCC there. And there you go. That's going to be the schematic symbol for the chip. It's also good practice to define the electrical type for the pin. So is this going to be an input or an output, or is this going to be for power stuff? So for I2C, it's going to be input-output because it can receive and transmit signals. For OS, or our over temperature shutdown, we know that's going to be an output. Our ground pin, that's going to be power. And then our addressing pins, these are all going to be inputs, so I'm not going to change those. And then VCC, we know that's going to be power. And then if you're happy with everything here, you can click place symbol, and it just pops it right in the workspace for you. And you can drag it around if you want to, or just leave it in the default location. I am just going to I'm just going to leave it right there. And and that's basically it for your schematic symbol. Okay, now that we've completed our schematic symbol, I want to draw your attention to something. If we go to our OneNote, under Team Notebook, Electrical Section, Main, there should be a page in here called New Component Standards. And basically, this is a list of standards our team has put together that your PCB footprints and schematic symbols must satisfy to be used in our designs. So the idea is you create your schematic symbol, you go through this checklist, just check off all the boxes and make sure your schematic symbol makes or satisfies this criteria. Go through, make your PCB footprint, go through the checklist, and check everything off. And then after you're done finalizing your component, you reach out to another member of the team. You say, hey, can you look over my design? Give them a week to look over your design. They check over your work to make sure that there's no mistakes. And these are basically just to ensure that whenever we create schematic symbols and footprints, you go through it pretty quickly. It's pretty easy to make mistakes. I know I've made plenty of mistakes when doing this stuff, so these checklists are a way to compensate for that, and also just to make sure when we're using stuff in our PCBs, it's all standardized and looks nice, and same thing for the schematic symbols. Okay, I just want to point something out. If you're new to the team, this is a very handy table. It basically just lists all the designators and all the parts that they designate. So we use U for integrated circuits, J for data connectors, P for power connectors, Q for transistors, and so on. So if you're ever confused about, okay, what letter designates what, you can refer to this table on this new component standards page. Back to these two checklists. So whenever you create a new component um, for your project, what you do is you copy these checklists, go to your project notebook. So whenever we have a project or a board that we're doing, it has its own OneNote notebook. And as you can see for this project here, there's a section called components. So whenever we create a new component or a new schematic symbol or footprint, we create a new OneNote page for that component specifically. Paste your checklists in, check through everything, and then get someone else to look it over as I've done on this page here. So as an example, I'm just using this notebook and pasting this page in here for our temperature sensor. So I have the checklist in here. So we're just going to go through row by row for the schematic symbol right now. So the first thing we want to do is ensure part designators follow as given in this document. So basically that part designators table here, we want to make sure it lines up properly with the part. Since this is an IC, we use the letter U. So that is all good. So I'm going to check that off. Make sure the schematic name is correct. So basically the schematic symbol name is the name of the part, and the file name is also the name of the part as well. So we check that off. Description in datasheet is available. This is stuff that we will enter in the Excel sheet. I usually leave this till the end when I'm done the schematic symbol and the footprint, so I'm just going to skip over this for now. Ensure pins are not exposed from the top or bottom of the schematic symbol. Exceptions include op amps, MOSFETs, and other logical symbols. So unless there's a component where it's standard that we have pins coming from the top of it, make sure all of your pins just come out from the sides, as we've done here. So I'm going to check this box off. So the next thing we want to check is pin numbering starts at 1 and never at 0. Just check the right box there. So basically we never start pin numbering at 0. Pretty simple. Check that off. Make sure pins are 200 mils in length. Just make sure they're not too long. This row here is a little bit worded a little bit weird in the fact that not all of your pins have to be 200 mils long on every component you make. Just make sure your pin lengths aren't too long, like 250 or 300 mils. That's pretty long, and just make sure they're not too short, like 50 mils. That's very short. Try to make sure they're like 150 to 200 mils is what I'd say. Maybe go down to 100 if it looks okay, but just kind of use your visual judgment and just make sure it looks good. So I'm gonna select all the pins here. So I'm just gonna go find somewhere objects, apply. Okay, and there we go. It should only allow me to select pins. And since these are 100 mils in length, I'm going to bump this up to 200. If you guys don't know what mils is, it's just an imperial unit. It's like an imperial unit of measurement, and it's 1,000th of an inch. So whenever we do schematics, it's always in mils, and then when you're doing layout, it can be in millimeters or mils. So there you go. So now we can see that our pins are a lot longer, and they look a little bit nicer. So I'm just going to clear the filter. So let's go and check that box off. Schematics are to be done using an 100 mil grid. So whenever you make a schematic symbol or place like any pins on a schematic symbol, make sure it's on an 100 mil grid. Right now I'm using a 10 mil grid, so this is you don't want to be using a 10 mil grid. So if I press a G on my keyboard, we get back to 100 mils, and you can go down to 10 mils, 50 mils, 100 mils. So 100 mils, when I'm dragging the component, obviously it's a lot more spaced out where it moves, and we'll just drag it back there. So whenever you're placing pins, make sure it's an 100 mil grid. If you're doing like graphical stuff, like drawing a squiggly line on a resistor or doing a diode, obviously it would be more imperative or useful to do that type of work on a smaller grid size. But yeah, just make sure you're placing your pins on an 100 mil grid. But we got Altium to automatically do that for us, so we're all good. Ensure all pins lie on the 100 mil grid. So this basically means the end of the pins here, where you see this white, these four white dots. This is where you connect your wires up to. We have to make sure these lie on the 100 mil grid, just to make sure all of our schematics, or when we're doing our schematic, everything's on the same grid, I guess you can say, so it's very convenient to wire things up. So as you can see the outlines of these boxes. It may be hard to see on the uploaded video form, but when you're in Altium, it'll be a lot clearer. And you can see that the ends of these pins all lie on that grid. So basically, if I were to change this pin length to 150 mils, you can see that the edge of this pin lies in between this 100 mil square here, and that would be incorrect, so that wouldn't fly with our standards. So you have to make it 200 mils. In some designs, you may actually need an 150 mil pin length for it to lie on the 100 mil grid. So just be wary of that. Really just depends on the schematic symbol you're doing. So we can check that off, and I'm just going to leave all the rest of this stuff, um, and all of it's pretty simple. So I'm not going to go through the rest of it and drag out the length of this video, but hopefully you get the idea of what to do. And just another remark I'd like to make is that this list right here, this checklist, some of these rows, not a lot of them, but some of them operate based on our own old library system. So if you see anything that doesn't make sense, or something you don't understand, it's probably because it refers to our old library systems, not our new ones, which these videos are based on. Um, so if this checklist looks a little bit different when you're going through it, don't worry. Or maybe maybe the checklist hasn't been updated yet and there's something you don't understand. Maybe just reach out to someone else on the team, or just skip over it if you don't understand what the criteria is. So I just wanted to make that clear.